Okay, so in this video we'll solve the question I have on the screen, which says that the figure shows a waiter at a restaurant serving a drink and rice meal on a tray. The center of gravity is defined to be the average position of the weight distribution of the object the waiter carries. The weight of the wine, tray and rice are what? 12, 8 and then 10 newtons respectively. The positions are also shown. We should find the center of gravity. Okay, so let me explain the question. So you see that this waiter here, okay, is carrying a bottle of drink, a tray, and then this rice. Okay, you see that all these objects here has weight. Okay, all these objects what has weight, but the waiter has been able to what balance this weight on his what on his hand. Okay, the waiter has been able to balance all this weight on his hand. Okay, so what you are going to do is that you are going to find what a weight, okay, which is equal to what all this weight here, and then you find its position, which is known as what the center of gravity, where when that weight acts, it will also cause what the pan to what to balance on the what the waiter's hand. You get it? So you have a weight here, you have a weight here, and then you have a weight here. Okay, so you represent it with what a single weight, which will cause the same effect as what this weight are also causing. So you are going to find a weight, and that weight will also cause what this system to be balanced on what on the waiter's hand. Okay, and the weight will be easy to find because you can just add all these weights here, and then that will tell us what the total weight or that you have what at that point, since it is what equivalent. So the sum of all these weights here will be equal to what that single weight that you want to what represent. The main thing that we have to calculate is what where we put what that weight, that total weight, to make it what produce the same effect that all these weights would also produce. And that position is known as what the center of gravity. So first of all, we are going to find what the resultant weight. Okay, so after finding the resultant weight, then you find what its position, or the position where the resultant weight was what will act to make will act, okay, to perform the same effect that all these weights are acting. So without wasting much time, let's go ahead and then look at it. Okay, so first of all, you are going to find out the resultant weight. Okay, you are going to find out the resultant weight or the total weight. Okay, so now I'm going to add all these weights here. Okay, I'm going to add all these weights here and then represent it but as a single weight. So you know that this weight is acting in the negative y-axis direction, same as this, same as this. So they all be what negative. So I have minus 12, minus 8, and then minus what 10, and this will give me minus 30 newton. Minus 30 newton. So the negative sign there is telling us that what the force will be what acting in the negative y-axis direction. So let me draw my equivalent force system here. So let's take this to be the pan. Okay, this to be the pan. The force will be acting here since it is negative. Okay, so I have my 30 newtons here. Okay, so now let's locate point A. This is point A. Okay, and the distance from here to here, let's make it distance x. Okay, all right, so let me draw this system here also. So I have the first force here, I have the first force here, the second one too is here, and then the last one too is also here. Okay, so this is my point A. Okay, this is my point A here, and then this is the 12 Newton force. This is the 12 Newton force. This is the 8 Newton force, and then this is what the 10 Newton force. And the distance, the 12 Newton force is from point A is what 12 centimeters. So this is 12 centimeters. Okay, and bring the Newton sign. This is 12 centimeters, and then from this side to this side is also 18, and then from this side to this point is also what, 16. So you know that for the 4 Newton here, its distance from point A is what, 12, and then the 8 distance is what, 12 plus 18, which is 30, and for the 10, its distance is what, 16 plus 18 plus 12, which is what, 46. And we know that we have represented all these forces here, okay, with a single force here, okay. So what you are going to do is that you want to find the location where when we place this force, it will produce the same effect as this. That is, it will cause the what, the pan, okay, to balance on the weighted hand. So where would that force act? And that position will be what, the center of gravity, because that's the point where all the weight of an object what acts. So since this is the weight of all the objects, you are going to find the position that you have to place it in order to also cause the pan to be balanced. Okay, so let's do that. So now we know what, a specific distance, a specific point A, okay, on the pan, and we know the respective distance that each of the force is from what, that point. Okay, so when you're able to find the moment, okay, of the forces from that point, and you find the resultant of that moment, this resultant or this equivalent force here should also what, produce the same moment that these forces what are producing from that point A, since they are all the same. So now you are going to find what the moment at this force is what will cause about point A, and then also find the moment that this force will also cause what at point A, and that will help us to find what the distance or the location you have to put place the 30 Newton force here, okay, to help the system to be balanced. So you are going to consider the moment of what each of these forces here. So the moment of the first force will what, 12 times 12, which is the first times of the perpendicular distance. By looking at where the point A is, it will cause what, a clockwise moment. Same as this 8 Newton here, it will also cause a clockwise. This 10 Newton also what, cause a clockwise moment. So this will make their moment to what, to be negative. So for the first one, I have what, minus 12 times 12, okay, plus minus 8 times what, the distance, which is what, 30, okay, plus minus 10 times 46. You know, I negated them because they are causing what, a clockwise moment, so their moment will be negative. So this will give me minus 100 and what, 44. Then this will give, so this minus 200 and what, 40. This also gives me minus 400 and what, 60. So now let's find the resultant moment. Okay, so minus 144 minus 240 minus 460. This gives me minus 800 and what, 44 Newton centimeter. So looking at this, of course, this moment should be negative. Do you know why? The reason I'm saying that this moment should be negative is that they are all acting on one side of what, point A. Okay, so you have something like this. This is point A, okay, and all these forces here are acting on one side of point A. So what does that mean? When they all act, they will cause the pan to turn this way, right? Since none of them is what, acting on the left side of what, point A. So when these forces are all acting, they will cause the pan to turn this way, which is what, a clockwise moment, and of course that's what, a negative moment. So that's how can we have our resultant moment here to be negative. Okay, so now we know our resultant moment. Okay, we know that the moment that this force is will cause should be equal to the moment that this force will also cause. So what will be the moment of what, this 30 Newton force here? It will be what, 30 Newton here times what, the perpendicular distance was from point A. But we don't know this perpendicular distance. Okay, that's what you are going to find. So now you know that this force will also cause what, a clockwise moment due to what it is. So its moment will also be what, negative. So the moment at point A for that resultant force is what, minus 30 times what, the distance x. So which will give me minus 30 x. Okay, so we know this, alright. But we know that since this force equals what, this force is here, the moment that these forces will cause will be the same as what the moment that this force will also cause. So for that reason, we can equate this moment to this moment, then we will to what, find our distance x, which is what the center of what, gravity. So let's go ahead and then do that. So let me clean all this. Okay, so the moment that all these forces here will cause is what, equal to minus 844, and the moment that this force will cause you what, minus 30 times what, x, and you want to find this x, and since this moment equals this moment, we can equate it and then we find our distance x. So that I have minus 30 x equals what, minus 844. Okay, so now divide both sides by minus 30, divide both sides by minus 30. So this will cancel out. The negatives also cancel out. So at the end, I have 844 divided by 30. And this gives me 28.133 centimeters. So this tells us that when you place the equivalent force, okay, let me draw it again. So I have this here. Okay, the equivalent force is here. Okay, and this is my point A here. Okay, so let me locate the distance here. So this will be my distance from point A. Okay, so what this means is that when you place this 30 Newton, this 30 Newton weight at a distance of what, 28.13 centimeters from point A, it will cause the pan to balance, since that is what, its center of gravity. So this system here will produce the same effect as what all these weights are producing here. So our distance from point A, where you have to what, place the resultant force for it to what, cause the same effect as these forces will cause with what, 28.133 centimeter from what, point A.